Okay, we have level 2 calculus 2012 exam. Question 1. A function f is given by this. Find the gradient of the graph of f at the point x is 2. So the gradient function is f dash of x. So that's our gradient function. How do we derive? We go 2 times 3 is 6. Take the power down. 3 minus 1 is 2. Minus, there's an invisible 1 here. 1 times 10 is 10. We keep the negative sign. And take the power down. X to the 0 equals 1. So it disappears. And if we imagine that as 5x to the 0, 0 times 5 is 0, so it just disappears. Now we write f dash of 2 because we're wanting to find the gradient of the graph of f at the point x equals 2. So here we've got 6 times 2 squared minus 10, which is 6 times 4 minus 10, which is 24 minus 10, which is 14. So the gradient of f of x is 14 when x equals 2. Let's have a look here at the answer, and that's all you needed for achieved. Okay, moving on. For a function p dash of x equals that. The graph p passes through that point. Find the function p of x. So p of x equals, now I have to undo my differentiation. So I'm going to call that 4x to the power of 1. Oh, sorry, to the power of 0 minus 6x squared. So I've got to raise the power and times it at the front by the new power. Raise the power to 3. Oh, sorry, divide by the new power. If I have got ax to the n going to a n x to the minus 1, to go from there to there, n minus 1, to go from here to here, I'm multiplying these two together and taking the power down. To go here to here, I'm adding 1 to the power and dividing by the new power. So I'm adding 1 to the power to get x to the 3, divide by the new power, leave the 6 there, and so that's 4x minus 2x cubed. Now remember that if my n was 1, if I had a 3, it disappeared, or any sort of constant, it disappeared. So I need to say some kind of a constant here. So this is my p of x. Okay, now what we've got is point sub in 2, 5. So 5 equals 4 times 2 minus 2 times 2 cubed plus c, and we're going to find c. So 5 equals 8 minus 2, 2's are 4, 2's are 8, 2's are 16 plus c. So c equals 8 minus 16 is negative 8, and then it becomes plus 8 on the other side, so 8 plus 5 is 13. So I'm thinking c is 13. So I'm thinking that p of x equals 4x minus, minus 2x cubed plus 13. Now let's have a look. That is correct. How would I actually test that on my calculator? I think that's a really good good thing to do, is to actually test it. So let's get the calculator out. Okay, the graph passes through the point 2, 5. So let's actually just graph. Oops. Better get it back to menu and get into my proper graph thingy. I'm going to graph my original function, which is 4x squared minus 2x cubed plus 13. And I might just go zoom auto and see what happens. That looks better. Okay, now I'm going to go gsolve, and I think I want a ycalc. Now when x is, let me go back to my question. There was my original graph. The graph of p passes through the point 2, 5. So let's have a look. When x is 2, y is 13. I must have done something wrong there. What have I got? Exit, go down. That was 2x cubed. Wasn't x squared, was it? Terrible. That we will delete, and x cubed, and gsolve, and a y calculation. So x is 2. And I'm hoping that y is 5. Right. And I wonder what the gradient is at that point. So if I go shift setup, I can put derivative on, and I can trace, and I'm wanting point 2. The gradient, y by dx is 3.7, oh that's 0.2, sorry, my bad. Let's go at the 0.2, just for argument's sake. At the 0.2, the gradient is negative 20. So if we plug 2 into this, then we've got 2 2s are 4, 6 times 4 is negative 24, 4 minus 24 is negative 20, so the gradient is negative 20. So I can prove on my calculator, really, that I have got it right.